Alright you guys, so we're going to do an experiment that's related to force and mass. Hopefully you know the concept that the greater the mass of an object, the greater force you will need to get that object to change or move direction, or speed for that matter. So we're going to come back to this equation you see at the top, but here's what we're going to be doing. I'm going to focus in on our actual experiment. What we have set up here is 3 separate balls of all different masses. So I have like a soft squishy ball, I called it a foam ball. I have a tennis ball, which we're all familiar with, and I have a lacrosse ball. All different masses, and I'm going to prove it because I'm going to show you on my scale what they are here in just a second. And what I'm going to do is I'm going to take these balls from this consistent or constant height, and I'm going to roll them down this ruler and see exactly how many centimeters it pushes this blue cube over. So every time I do this experiment, I'm going to start at 0 centimeters exactly, and as an example, I will put this up here, it will roll down and push that cube. All right? Hopefully, if the theory of greater the mass, the greater the force that it'll push it, means that the lightest ball, which would probably come in as a foam ball, won't push our blue block nearly as far as our lacrosse ball. But that's what we're going to do this experiment to prove. So first things first, I need to take the mass and write them down on this board of these different balls. So let's go ahead and turn my scale on. This may take a second to balance these out, but let's give it a try. So the Adventure Park foam ball is 25 grams. All right, so I'm just gonna write these right next to it, 25 grams. The next is the tennis ball. The tennis ball comes in at exactly 60 grams. 60 grams. And that brings us to our last ball, which is the lacrosse ball. I knew this one was gonna roll off, but I got 145. 145 grams. So now what I'm going to do is I'm going to set it up, just like I told you a second ago. I'm going to drop the ball from the exact same position on this ruler, let it fall down at the exact same acceleration or rate until it hits this blue dice to see how many centimeters it actually moved. I will do it 2 times, then take the average like I've done for the other experiments, and then we'll come back up to this formula and talk about it. So let's begin. All right. So I'm going to start with my, there it is, make sure we're set up right. I'm going to start with my foam ball. So it's at 0 centimeters. Let's put it at the very top. Let's let it roll. And it just went 5.5 centimeters. So I'll write this down, 5.5 centimeters. I'm going to go ahead and try it one more time because we're going to do 2 trials. 1, 2, 3. This one now went 4.5 for trial 2. So if I were to take the average of the 2, I'd add them up and divide by 2 because we have 2 trials. The average is going to be 5 centimeters. All right, let's bring this back to 0. Let's now use the tennis ball. Start it at the top, 1, 2, 3. Look at that, we got about 10.5 for trial 1. 10.5 centimeters. Now let's do it again for trial 2. Right at 10.5. 10.5 centimeters again. So our average, I don't have to do any math there, would obviously be 10.5. The last one I need to test is a lacrosse ball. So I'm going to go ahead and give this one a try. I'm going to put it up here, same location that I'm dropping it at. Let me just move this over. 1, 2, 3. Whoa, look at that. That went way past my mark. If I had to guess, this would be 30 centimeters. Let me go here. This would be about 33 centimeters. 33 centimeters for trial 1. Let me let everything be the same again. Bring this back. All right, here we go. Second trial. 1, 2, 3. Oh, it fell off. That won't work. 1, 2, 3. All right, this one went to 27. 27. So again, I can just do the math in my head. 33 plus 27, you're going to add them up and divide by 2. You're going to get an average of 30 centimeters. All right? So this one is all about the mass. So we changed the mass to see that the force would also change to push the block further down the line. So again, the concept is the greater the mass, right, lacrosse ball, the greater the force or the push on the actual cube. We just proved that. But now we're going to try a different one. We're going to try everything about acceleration. So I'm going to go with a cube that's like, a ball that was like in the middle range, 60 grams. So right here. So I'm going to keep my mass consistent, all right? And what I'm going to do is see how can I change the acceleration. The previous experiment, I kept the same acceleration because I kept this constant. 3 textbooks high, the same ramp, the same slope. All I did was change the mass for experiment 1. Now I'm going to keep the same ball, but I'm going to start with 1 book height, 2 book height, and then 3 books tall, and see how the acceleration changes. Okay, so now same mass. So a very similar experiment. We'll go ahead and none of these matters because we're only going to do the tennis ball. So I'm just going to scratch this out, and let's go ahead and zero this out. This is from 3 books high. Look at that. It went to 20. So the tennis ball, wow, that's a lot further than we got in the beginning. That one stayed right behind it. So we got 20 centimeters. Now what I'm going to do is go 2 books high, set it up again, right there. 2 books high, here we go. Change the acceleration rate because now it's a little bit lower. So that means I've decreased the potential energy. It's at 11 centimeters. And now what happens if I go to 1 book? Okay, here we go. I don't think anything's going to happen here, but it's worth a shot. 1, 2, 1, 2. I can't even make it go down this. Oh, go down the ramp. Stay. Go, go, go. 6 centimeters. All right. So the second experiment that I just did with you guys proves that the force will change even if the mass stays consistent, but we're changing the acceleration rate by changing the height or potential energy that I dropped this ball from. So when I dropped it from, this should change a little bit, but when I dropped it from, instead of T1, I'm going to say something different. 3 books high, we got 20 centimeters. When I dropped it from 2 books high, we got 11 centimeters. And from 1 book, we got 6 centimeters. I'm not going to take an average per se, but just know that the force changed because I changed the rate of acceleration. So that's an experiment that kind of goes over the concept how mass is related to force. Hopefully that made sense to you guys. And let's make some conclusions. All right, you guys, I want you to know this real quick. I know I kind of didn't do this in the other video, but just to prove that mass and acceleration create force, or that force is related to these 2 concepts, I know you saw me do the ones with the different masses, and you saw me do the tennis ball where I decrease the height or potential energy from which it's dropped at, therefore decreasing the distance that this travels. But I wanted to prove that I can do the exact same force if I change the acceleration. So look at the foam ball. I want to try to see if I can hit that 6 centimeter mark, which I did just a second ago by trying this. But I'm going to go 3 books high, I'm going to drop it, and yep, there we go again. I'm right at 6 centimeters. So you can get the same force by changing either one of these things. So in other words, if let's say the answer up here is 2 newtons, all right? You can either have your mass be 2 times your acceleration of 1, or you could flip it inversely and have the mass be 1 and your acceleration be a rate of 2. So just realize that these 2 things will equal the output of the force. So based off your mass or acceleration is how